So today in section 8.2, we're going to talk about adding and subtracting rational functions. Now you might be wondering, why is it that we have to add and subtract after we've already multiplied and divided? But remember, multiplying and dividing is always much easier when it comes to fractions, because multiplying and dividing is just a cross thing, where adding and subtracting is much different. You have to have common denominators and things like that, which might not be very easy when we're talking about variables. Now, remember, if we want to add two numbers, like here's an example, 5, 6, and 4 ninths, we have to have a common denominator. And so for us, that common denominator would be 18. And so we'd say that 5 sixths is really equal to 15 eighteenths, right? Because we multiply by top and bottom by 3. And 4 ninths is really 8 eighteenths, because we multiply top and bottom by 2. And then I can add them together. And so I would say 15 eighteenths plus 8 eighteenths would be 23 eighteenths. And we can always leave our answer as improper fraction like this, okay? Now the same is true when it comes to polynomials. We just make sure that the bottoms have the same factors. And so we're going to get something goofy or interesting, I guess, more or less, like this. And it's going to be really big, but that's okay, because then when we start adding, maybe it will be easier and we can simplify, but who knows, okay? All right, let's look at example 1. It says, find the least common multiple of each of the polynomial sets. So really, all we're asking to do is look between 6, okay, 15, and 9, right? So what are the factors of 6, 15, and 9? Well, the factors of 6 are 3 and 2, right? And 15 would be 3 and 5, and 9 would be 3 and 3, right? So notice they all have a 3 in common, so that's good. So it means our least common multiple is going to be 3, okay, this one that they all share in common, and then everything they don't share in common. So 2, 5, and 3. That's how we figure it out. And so if you multiply all those together, 3 times 2 is 6, times 5 is 30, times 3 is 90. So the least common multiple for the number part, which is always the hardest part actually, is 90, right? Then I say, okay, well, this number has 1x, this one has 2 x's, and this one has 1x. So the least common multiple of all of them would be 2 of them, right? Because I could give this one an extra one, and I could give this one an extra one, but I don't have to give the middle one an extra one, so it'd be x squared. Then I look at the y's. So I have 1y here, I have no y's here, and I have 4 y's here. So the least common multiple would be 4, because I could give 3 to here and 4 to here. So here is my least common multiple between them, okay? All right, let's look at letter B, which is going to be significantly more difficult. Now, why is that one more difficult? Well, I'll show you why. Well, first I'm going to do, I have to break it down. So notice in here I have y to the fourth, y to the third, and y to the second. So I'm going to take out a y to the second, and I get y to the second plus 8y plus 15, which I can break down even further, right? I can actually say the two numbers that multiply to 15 and add up to 8 are going to be, let's see, 5 and 3. So this is actually y squared, and then it's going to be y plus 5 and y plus 3. Okay, that's the first one. Now the second one, okay, y squared minus 3y minus 40. I can't take anything out, and I notice that I have, let's see, I'll just write it right here, y squared minus 3y minus 40, right? And so what I can see is, my AC is negative 40, and my B is negative 3. So the two numbers that multiply to negative 40 and add up to negative 3 are going to be negative 8 and positive 5. So it's going to be y minus 8 and y plus 5. Now, you'll notice that I have y plus 5 in both of them. So that's my first factor, right? Just like I did with the numbers, y plus 5 is the first factor. And then I have to add everything else in. So I have a y squared, and I'm going to put that in front because I don't like that kind of in the middle. And I have a y plus 3 And then I have a y minus 8, right? That is just all of my least common multiple, okay? All right, a couple guided practice problems that you can try too. Now again, adding and subtracting rational expressions are very similar, but the one thing we notice is we have to have a common denominator. Okay, and if we want a common denominator, we have to use our least common multiple to find it, right? So that's why we just practice that, is so that we can find our common denominators when we add and subtract, and that's by finding the least common multiple between the two, okay? All right. Okay, so we are going to, let's see, we're going to add these, right? We're going to add them. Now, if we're going to do that, we have to have a common denominator, right? And so the least common multiple between 2 and 8 is going to be 8, right? And so, actually, you know what? We'll write it down over here. Least common multiple, right, is going to be 8. And then I have an x to the third and x, so it's going to be x to the third. And then I have a y squared and the 1, so it's going to be y squared. So I need my bottoms of both of my fractions to be 8 x to the third y squared. So I'm going to take, and I'm going to say, how do I get 2x to the third into this? So I need to multiply the top and bottom by 4, because 4 times 2 is 8. I don't need to worry about the x, but I do need to worry about the y squared. And so I have to do it to the top also. So I'm going to get 8x to the third y squared on bottom, and 4y squared times 3y is going to be 12y to the third on top. Okay, let's go to our next one. All right, we're adding, and so we need our bottom to be 8x to the third y squared, which you'll notice that means I just need to multiply top and bottom by x squared, right? And so I get 5x squared z. So now my job is to add them together, and you'll notice that the bottoms are the same, 8x to the third and then y squared, and I just add the top, 12y to the third plus 5 x squared z. That is my addition problem right there. And you'll notice the top still has an addition problem. That's okay. But we do have a bottom that is the same. All right, so here's a couple guided practice problems for you to try now. All right, so the last ones we're going to look at here are ones in which we have more or larger denominators. We have polynomials in our denominators, right? So first off, if I look at this one, the least common multiple, we got to figure it out. So for the first one, my factors are, I'll take out a 6, and then I get x minus 3, right? That's the first one, okay? The second one, I can take, well, it looks like I can take a 2 out of everything, right? And then I get 2x squared minus 7x and then plus 3, right? Which actually is just 2. And then 2 times 3 is 6. So the two numbers that multiply to 6 and add up to negative 7 are going to be, trying to think off the top of my head, I would probably say negative 1 and negative 6, okay? So that would be, then I would break it down. So it would be 2x squared minus 6x minus 1x, and then it would be plus 3, right? And we can break that down. So using factoring by common difference, right? It ends up being, let's see, we get 2x minus 3. No, we take out the 2x. Let's see. Let's actually do it. All right, 2. And then I get 2, and I take that out. So it's take a 2x out, and I get x minus 3. And then the next one, it would be a negative 1, and then x minus 3. So my factors are actually 2, and then I get 2x minus 1, and then x minus 3. And you'll notice I have, when I do that, I have an x minus 3 here and an x minus 3, so that's our common difference. Between 2 and 6, I can turn them both into 6. The x minus 3 is going to be the same in both of them. And then I also have to add this guy right here, the 2x minus 1, okay, to make it a common denominator, all right? So I'm going to do all my work over here, right? Okay, and so we're going to get, all right, so the bottom between this guy right here and here, I have the 2x minus 1. So I'm going to multiply the top. So it's going to be 5 times 2x minus 1, okay, all over my least common multiple, which is 6, and then x minus 3, and 2x minus 1. And then I'm going to subtract it from this whole guy. But you'll notice what I have here and my least common multiple, the only difference was I needed to multiply the top by 3, right? So I'm going to do that. So I'm going to multiply the top by 3. So it's going to be minus, and then 3 times x minus 1 all over, and then it's going to be 6 x minus 3 and 2x minus 1. Now you might be wondering, why does it look different since we didn't really change much besides the 3? And that's okay, because we're allowed to keep it looking like that, right? And so what I'm going to do is I'm going to distribute this 5, and then I'm going to distribute this, we'll call it a negative 3 actually to both of them, a negative 3 to both of them. And we get 10x minus 5 minus 3x, and then plus 3, all over my whole least common multiple. Okay, and so then 10x minus 3x is 7x, and then minus 5, and then plus 3 would be minus 2 all over the bottom. So this is my least, or this is my, the end of my subtraction problem right here. All right, a couple guided practice problems for you to try. And we have one final problem, example 4. Now, this one looks really scary. Why does it look scary? Because it's got a fraction over a fraction. We got 1 plus 1 over x divided by 1 minus x over y. So to make this less scary, let's write it out like this. 1 plus 1 over x divided by, and then we're going to do 1 minus x over y, right? We'll write it like this. It normally doesn't look as scary, because what we can see then is I have to have a common denominator for both of these, right? So for the top one, or this guy right here, my common denominator is going to be x, right? So I really have x over x plus 1 over x, which is just the same as x plus 1 over x, right? Then for this guy over here, my common denominator is going to be y. So I had y over y plus, or it's actually, minus x over y, right? And so that's just the same as y minus x over y, right? And so what we can do is, since it's a division problem, we're going to multiply by their reciprocals. And so we're going to say x plus 1 over x times y over x, or y minus x, right? And so our final answer is just y times x plus 1 all over x times y minus x. That's our final answer. And again, so we go from something that looks like this to something that looks like this. All right? Okay, couple guided practice problems for you to try. Good luck. Let me know if you have any questions.